Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In this lecture, we'll start with the new method of solving the differential equations. This method is known as Runge-Kutta Method. In Runge-Kutta Method, this is similar to Euler's method, which is used when the x and y's both are given in our question and we have to solve it, and x are not the power of y's, then only we can solve it by Runge-Kutta method. And in this method is also a step by step method, similar to Euler's method, and is not equal to iterative method as Picard's method. So that is the difference between all three of them. They might ask you in the examination, so this is also an important point for your examination point of view. And let us begin today's lecture. This is Runge-Kutta method. This is also an important part of your syllabus because it has been asked several times in your PYQs, and we'll do some of them today also. So what does this method denote? Let us say that we have to find y1, y2 and all those things again and again here also. So before finding that, we have to find some of the terms which are, let me derive the terms. Let me say that we have to find four terms. K1, you just need to learn, no derivation is required for your answer. You have to directly learn the results. There are four K4s. Let me just write them down, what are they, and afterwards when I write the formula, then you will know how and when do we require them. K1 is nothing but equal to h into f of y in f of t n minus 1 comma y n minus 1. T is nothing but x. When we keep it in the function, it is denoted by t. You can write t n minus 1 or you can write x n minus 1. Both of them are equal. Now the second one is h into f t n minus 1 plus h by 2 comma t y n minus 1 plus h by 2. This is your h2. And here, instead of writing h, we will write k1, which we have found in equation number 1. Now this fourth one will be h into f t n minus 1 plus h by 2 comma y n minus 1 plus your k2 will come, k2 upon 2. And the fourth one is h into f t n minus 1 plus h into and y n minus 1 plus k3. I hope that all of them are clear. Where t is the notion for x values only. When we use it in a function, we denote it by t. And h is the width, sample width. H is nothing but xn plus 1 minus xn, the width. And k1, k2 and k3, I have all told you what comes here. Now if we want to solve the question, so there might be four orders. If we have to solve the question in first order, if the examiner says that solve this question for first order of Runge-Kutta method, then what will be your formula? Your formula will be, for first order, will y1 should be equal to y0 plus h into f x0 y0. If you notice this, then this is exactly equal to Euler's method that we did in the previous lecture. this is exactly equal to that. So Runge-Kutta's first order is exactly equal to Euler's first method. This one is done. If the examiner tells you to calculate it till second order, calculate it for second order, then we'll directly apply the second order. We won't be deriving the first and then second. We directly apply the second, but we have to derive those k1, k2, k3 and k4. Okay, so this will be y1 is equals to y0 plus half into k1 plus k2, which is the arithmetic mean of k1 and k2. This is your second formula. The third formula is for the third order. If the examiner tells us to calculate for third order, then it will be equal to y1 is equals to y0 plus 1 upon 6 to k1 plus 4k2 plus k3. Okay, this is the formula, and this ratio is very important for examination. And the fourth order will be, till fourth only we have to do. The fourth order will be equal to y1 is equals to y0 plus 1 upon 6 k1 plus 2k2 plus 2k3 plus k4. And that's your Runge-Kutta method. K1, K2 and K3 and K4 have uses in here, and their formulas are here. So this computes our Runge-Kutta method, and not in the examination, not much of the calculation comes, because the formula is all hard enough that they directly can ask you formulas. And the kind of questions they ask, that also we'll do. That is not a tough one, it is easier one. The demand is only that we should know the formula for calculating Runge-Kutta method. So let us move to the kind of questions they ask in the examination. So let us see this question. If you've noted it down, then let us take it here only. When we notice Runge-Kutta method here, first the first letter has been given to us that it is a Runge-Kutta method of order 4 is used to find the solution of differential equation, where y0 has been given to us as 0 and x0 is also given to us as 0, with step size h only has given if the solution is. So we have to calculate for fourth order. First of just see the order, then only you can move forward. And this has been calculated for our fourth order, where h is this and y0 and x0 is this. If I mention it for fourth order, we know that our formula was y1 is equals to y0 plus 1 upon 6 k1 plus 2k2 plus 2k3 plus k4. But as you can see is here, in here, that they have just maintained three values, a, b and c. So one must be but one must not be there in here. So that means in the question they have not correctly given us the fourth. It should be three order. For 3 the number should be 3, for 4 the number should be 4, for 2 the number should be 2, and for 1 the number should be 1. So instead of fourth order, we'll calculate it for third order, because the number is 3. Don't get confused in the examination. They confuse you by using this 4 and third order, but you can see the number of terms here and you can answer the question from that. So for third order, as we can say that it is 1 upon 6 bracket 1 upon 6 bracket k1 plus 4 k2 plus k3. Now as we notice this, the coefficient of this, for k1 it is 1 upon 6, for k2 it is 4 upon 6, and for K3 it is 1 upon 6 again. Now here the kind of coefficient we notice is 1 upon 6, 2 by 3 and 1 upon 6. They have confused you by using 2 by 3, which is again 4 by 6 only. So our option number D is correct. Rest of all, this is 1 by 6, 2 by 3, but not 1 by 6 at the end. Not 1 by 6 in the starting, not 1 by 6 in the starting. That's why the fourth option is correct. Now moving forward to another kind of questions that they have asked in the examination for Runge-Kutta method. Again they have said 4 orders, but they have given us 3 things. So here also we'll see for third order instead of 4. So just see the coefficient 1 upon 6. So first coefficient will be 3 upon 6, which is 1 by 2. So this option get cancelled. This is 1 upon 6 and 5 by 6. 5 doesn't come in this formula, so this also gets cancelled. 1 by 6, 3 by 6 and 2 by 6. This also get cancelled because there is no 3 by 6 in the formula. Here it will be 1 by 6, 4 by 6 and 1 by 6, which is the correct option. Again, the third order formula would be for Runge-Kutta y1 equals to y0 plus 1 upon 6 k1 plus 4k2 plus k3, and the coefficients are 1 upon 6, 4 upon 6 and 1 upon 6. Similar are the coefficients in option number D. So our option number D is the correct answer. Now moving forward to the question where we have to solve by using Runge-Kutta method for second order formula. Okay, so let us keep this aside. They've asked us the value for second order by using Runge-Kutta method. Here fxy have been given to us as 3x plus y square. So first of all, as this is a step-by-step method, so first of all we'll calculate k1, k2. In the second step we need both of them. So the formula for k1 is h into f of x naught and y naught, right? Here x naught and y naught has been given to us here. X naught is 1 and y naught is 1 by 2. And h also, and we have to find for x 1.1. So the difference between x1, which is 1.1, the h is x1 minus x naught, which is 0.1. So let us keep it in the formula. H is 0.1 into fx naught y naught. If we put the values of x naught y naught in fx y, then we will get the value 3 into 1, which is 3, plus y square, which is 1.44, which will give us the answer as 0.444. K1 we have got. Now calculating for K2. K2 has the formula as h into f x naught plus h by 2 and y naught plus k1 by 2. So it will be again h is 0.1, x naught plus h by 2. H by 2 is 0.1 and x naught is 1. 1 plus 0.1 will be 1.1 and 1 plus 0.1 will be 1.1 into 3 will be 3.3 plus y square, y plus k1 by 2. Y plus k1 by 2 will be 1.644 and its whole square will come out to be something like 0.590 and something. If we add and multiply all of them, then we get our answer something like uh, we get our answer here for K2. And then if we solve by using the Runge-Kutta method for y1 for second order, it is y naught plus half of k1 plus k2, which is equals to y naught is 1 plus half of k1 is 0.444 and k2 is 0.389 something. And if we divide and subtract, we will be getting our answer as 1.722 as our answer, which is exactly equal to A. This answer will come not exactly for 722 but 7189, and by taking the reciprocal, we will be getting the answer as 1.722 in to be exact. Till here, if also you can calculate, you will get the answer as 1.722, and from here also it will be 1.2. From here also you will see that your answer should be greater than 1.2. This D option and this C option gets cancelled, and only two options have the probability of getting being correct. So that's all for Runge-Kutta method. I hope that the concept is clear, and many of the questions has been asked on the same kind of concept. I have taken one from each one, and you can solve it by using this kind of concept only. If you have any doubt in the theory part or in the problem solving part, then you can ask in the comment section or on our WhatsApp channel. Only relevant doubts will be answered. All the best and thank you.